So here is an example of a cable system, and this problem is from Pytel's Statics of Rigid Bodies book, so you can check it out for yourself if you want to solve other problems involving cables. So for this problem, we are being tasked to find the height h and the forces in these cables. Um, and it is known that we have a 60-pound force applied here to keep the system in equilibrium, as well as these 40-pound weights. So I think it would be easier if we solve the forces in the cables first before we start solving for the value of h. So if you want to solve for the forces of these cables, let's draw the joints one by one. So it will be easier for us to analyze. So let's start with joint B. So joint B has the force BC. So I'm always assuming that the forces are in tension, of course, because they are cables, and cables can only resist tension. So this is the 40-pound force directed downward, and the 60-pound force directed horizontally to the left. So what we can do here is we can split the force BC into its components. And this will be BCY. So this will be BCX, and we can just use the summation of forces along Y and set that equal to 0 since the system is assumed to be in equilibrium. So I'm gonna denote the upward forces as positive. So we have the y component of BC, BCY, minus the 40-pound force. And that should be equal to 0. So we know that BCY is equal to 40 pounds. And if we take the summation of forces along x, assuming that the forces going to the right are positive, so we have BCX, which is directed to the right, and we subtract 60, which is going to the left. So we can solve that BCX is equal to 60 pounds. So now that we have both components, BCY and BCX, we can solve for the force BC by taking the resultant of these forces, the components. And with that, BC is equal to, let's use our calculators. So that's approximately 72.8, 72.111 pounds. So next, let's solve for joint C, because in joint C, we can solve for the force in CD. So what are the forces acting in joint C? So that's the force CD, um, the downward load of 40 pounds, and force PC. And to make things easier, let's draw the components again for BC. So the BCX is equal to 60 pounds, and we also have the BCY. Let's just put it below. BCY is equal to 40 pounds. So again, I'm assuming that every force is in tension since this is a cable system and cables resist tension. And to make things easier for us, let's also split CD into its components. So CDY and CDX. So again, same procedure. Let's just do the summation of forces along Y and summation of forces along X. So for summation of forces along Y, uh, we have an upward CDY, and let's subtract the 40-pound force and another 40-pound force, since this is the 40-pound force caused by this weight and this is the 40-pound force caused by the Y component of BC. So CDY is equal to 80 pounds. And we take the summation of forces along X. We have CDX in the positive direction, and we have uh, BCX, and also, and actually that's it. CDX is just equal to 60 because there's no other force acting besides this 60-pound force. So again, let's take the resultant. Sorry. Let's take the resultant of these forces to find CD. So that's 60 squared plus 80 squared. And again, if we use our calculators, CD is just equal to 100 pounds. So there we have the forces BC and CD. Now, how do we find the height H? So now that we know the y and x components of each of the cables, we can use those to find the angle being formed by the cables from the horizontal line. So I'm just gonna denote this height as h2 and this height as h1. Okay, so let's try to solve for h1 first. So in order to solve that, let's find theta 1 first, and then we'll solve theta 2. So theta 1 is just the inverse tangent of the y component, which is 40, over the x component of the force, which is 60 pounds. So using our calculators, 40 over 60, that's 33.69 degrees. And with that, we can solve for um, h1, since if we analyze this triangle being formed here, if this is 6 feet and we have an angle of 33.69 here, and this is h1, according to the trigonometric properties, the sine of 33.69 should be equal to the opposite side over the hypotenuse. So the opposite side is h1 and the hypotenuse is 6 feet. So if you transpose this to the other side, you can find that h1 is just equal to 6 sine of 33.69. So that is approximately 3.328 feet. And the same procedure applies for solving for h2. We just have to find theta 2 first, which is still the inverse tangent of the components of the force, of the resultant force. So for force CD to be exact. So CDY is just 80 and CDX is still 60. And using our calculators, we have 53.13 degrees. So that's the angle formed by this cable along the horizontal. So if we want to solve for H2, let's just say you apply the same property again, which is 6 feet, since the length here is also 6 feet. And we're going to multiply that with sine 53.13. And the answer should be 4.8 feet. So now that we have H1, we have H2, we can find the value of H, which is just the sum of both of these heights. And there you go. The answer is 8.028 feet. That is the height H in this problem.